Hello, this is Mr. Wyrick. I'm here to talk to you about lesson 8.2, which is the Pythagorean theorem and its converse. You're used to the Pythagorean theorem. I'm not going to spend a whole lot of time on this one. The work from the book should be pretty straightforward. There's just a couple of things we need to make sure we go over to make sure that you understand why we're covering this now. What we are going to be dealing with is a lot of proofs with right triangles. The proof that they do using the means and extremes to come up with the Pythagorean theorem is especially helpful in this case, so make sure you take a look at that. It should be on page 549. Actually, no, 547. They do that proof, and it's really good to look at that. Make sure you take a look at the book at that one. 8.4 is the Pythagorean theorem. It was discovered by a Greek mathematician that went by the name of Pythagoras. If we have a right triangle, and we know it's a right triangle, then the sum of the two legs of the right triangle squared will be equal to the distance of the hypotenuse squared. So here I have them labeled as A, B, and C. C is my hypotenuse. This is a right triangle, so I fill in the marking that'll make that a right triangle. And we know that A squared plus B squared is equal to C squared. That's how it's commonly said. Just make sure you understand and know when to apply that it's A and B are those legs, C is that hypotenuse all the time. It does make mention of Pythagorean triples. The most common ones are here: 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. On page 548, if you want to look at some, we just finished up talking about proportionality in chapter 7. If you have a 3, 4, 5 triangle, you could also have a 6, 8, 10 triangle, like multiplying them all by 2, keeping it proportional that way. This is still going to be a right triangle, but really just understanding that you can divide these all by 2 and end up with 3, 4, 5, you know it's a right triangle. It fits into that Pythagorean triple. So if you're looking at numbers, especially on standardized tests, the big ones, when they used to have the SAR test for geometry, and then on the SAT, the PSAT, the ACT, any kind of college entrance exam, most of the right triangles that they are going to give you are going to be 3, 4, 5 right triangles, because almost everyone knows that as a Pythagorean triple, and you can work those quickly if you know what you're doing. Coming down through here, the only other ones that I've seen on tests before are 5, 12, 13, and I think I've seen a 7, 24, 25 one time. It's pretty rare that they stray from the 3, 4, 5, but usually, again, they take a bigger ratio on the side, so it's 6, 8, 10, or 9, 12, 15, 15, 20, 25, anything like that, they're going to work, but I still refer to those as 3, 4, 5 right triangles. The next part of the chapter is talking about the converse of the Pythagorean theorem, and I think we have addressed this before when we were classifying triangles. If a squared plus b squared, the sum of the two legs squared, is equal to c squared, the hypotenuse squared, then it is a right triangle. Make sure you get that down in your notes. Make sure you understand what that means. If we have a leg that is 6 and we have a leg that is 8, and the other side then is 10, we know we are dealing with a right triangle, because a squared plus b squared is equal to c squared. If they just give you the measures and ask you to classify it, obviously if a squared plus b squared is equal to c squared, it's a right triangle. But then to revisit these, if the two legs when squared are bigger than the third one, a squared plus b squared is greater than c squared, it's an acute triangle, and a squared plus b squared is less than c squared, that's an obtuse triangle. If you need to go back, you can go back to the chapter, I think it was 2 or 3, where we were classifying triangles, and remind yourself on the acute and obtuse definitions, or just look them up real quick online. This is probably not going to be as much on your assignment today as this one. For the assignment today, we will do questions 9, there's a lot, 9 through 34. I'll skip over a couple of proofs there, and then we'll do 38 through 44, and then we need some word problems in there. We'll call it, just do number 50. Number 50. Okay, so this is what we are dealing with on this one, and we'll see you in class. If you have any questions, make sure to come into tutorials or check in with me.